You're listening to the WannaBes Mobcast.
Our podcasts are interesting because our guests
are interesting because we get cool people to tell us what's up.
We do. And today we have one of the coolest concepts, given where we've gone with the mechanics of our bikes. How many clutches did you say I blew up? 5 at least. My bike is literally in the shop with the clutch pulled apart right now because it blew up another one.
You blew up one on the 600. You blew up 3 on the
burned
beta.
out one on the 600.
Okay, burned out. Okay, but this is how many clutches you've
used up.
You've burned out 3 or 4 on the beta. You went back to the XR and you burned up 1, and now
I'm 2 clutches into this one.
You put the Rekluse in the 500, and then you.
I did. You're right.
And then you burned up the one on this 2-stroke, or you blew it up. But that's probably more of a mechanical failure than anything. But you still blew it up. So you're like 7 clutches in, and I'm still on my same stock clutch that I've been running the entire time.
So John went and found the clutch guy.
So Al Youngwerth
to come save us
is the original founder of Rekluse, the clutch company that everybody knows and loves. They make excellent quality clutches. And I hit him up and was like, hey, can you come and talk to us about all things clutches, right? Not just auto clutches, but manual clutches.
Yeah, for anyone who doesn't realize, Rekluse makes some amazing, very manual, very regular clutches.
Regardless of what you think about manual clutches, Rekluse makes very high quality stuff.
Yeah.
So with that being said, he's going to talk to us about, everything. We have a ton of questions for him, so we hope we can get to most of them.
How do I stop breaking clutches? And can you find me out of stock parts for my old dirt bike?
There you go.
Let's go find out.
It's going to be like, buy a new dirt bike.
Probably. But that applies to both of us at this point, I think.
Yeah, well.
But let's dive in. We really appreciate you coming on. We're excited to talk to you. We've both run various Rekluses. I will talk about it, but I blew up a lot of clutches. That's a whole saga. So we're thrilled to have you on. Do you want to kick off and let us know who you are and kind of how you got here?
Yeah. So my name is Al Youngwerth, and it's been a long journey to get here. So my journey with Rekluse really began when I first saw On Any Sunday, and I'm pretty sure it was a VHS recording. I got it. Yeah, there you go.
Shout out.
I think it came out in 70 or 71. Anyways, by the time I was about 8 years old, I had seen this movie, and I just moved to rural Gilroy, California, and I just immediately associated all the trails I was hiking around with my BB gun with these guys riding their dirt bikes and crossing the creeks and all that kind of stuff. So I wanted a dirt bike really bad, and so my first motorcycle was a JC Penney 3 horsepower, mini bike with the lawn tractor tires, the square ones.
It's the real deal.
Yeah. And that kind of started my journey. And I have owned most motorcycles continuously since then, coming up here on 50 years this year. Oh my God. I guess that kind of dates me. When I went to college, I went down to San Diego State, and really liked San Diego State, but too much concrete. Had an XL 600 that I terrorized the streets with. Got 3 exhibition of speed tickets on that motorcycle for wheeling. Had a hard time keeping that front tire on the ground. And then transferred up to Chico State. Got into mountain biking, and after I was graduating from college, one of my big objectives was I wanted to get back into dirt biking, seriously, like I used to ride all the time. And I had read a couple of years before an article where they interviewed Bob Hanna, and they said, what are you going to do after you're tired? He goes, well, I'm going to go back to Idaho, and that's where the best dirt bike riding is. And so I had in my mind that Idaho was this place I wanted to go check out. So there's a company that was interviewing at Chico State. I did the interview, came on site for the tour, and decided, this is what I want to do. And so that was in '89, and had kind of a career, and bought a dirt bike, and was riding the dirt bikes around the foothills here, kind of exploring around, getting a little bit deeper and deeper into the Idaho backcountry. And then in 2002, I'd been in a company that we had sold in like 1999, and I was consulting, kind of looking for my next major gig. Really was thinking I was going to do something in my background was in computer science, somewhere in high tech again. And I bought a new CRF 450 in 2002. And coming off of a KX 250 that had been set up for off-road, and love the power band, but man, that clutch was a lot of work, and it sometimes didn't seem to matter what you did with the clutch. The bike just stalled, and it could be a real bear to start. And someone told me, hey, about this new Revlock clutch, an automatic clutch out of Colorado. And it actually ended up connecting with, he was the guy that founded Fastway. I'm not going to remember his name. I want to say it was Josh. Anyways, ended up connecting with him, and he said, yeah, I got one, but I'm selling the bike. You want to buy mine? So I bought that, put it in, loved the way it worked, and really solved not all, but most of the stalling problems. But by the third ride or so, draining my oil was full of metal. And I'm like, what's going on? Take it apart, and like it's banging around in the cases. And so kind of take it all apart, figure out what's wrong, put it back together. 2 rides later, same thing. Contact them, and they're like, oh, you've done something wrong. Like I was very careful, all the instructions, put it back together, start doing some research on the internet, finding out other people are having similar problems or worse problems. And, about the third or fourth time in, I'm just ready to give up on the thing. I'm sure plenty of my customers have been there. So, I definitely have done far worse to many of my customers. But one of the things that we've always tried to do is do the right thing. If we screw something up, we try and really take care of it. They stopped returning my phone calls. So I was pulling it out, and I was pissed off. And as I was taking it apart, I thought, the reason why this thing doesn't work or it keeps having problems is they're hanging this 2.5 pound weight on the end of a clutch basket that was never designed to have any weight on it. And I thought, man, if we could move the weight to the transmission shaft, that would be, a lot better support. But then, no, it's got to spin with the engine. The transmission shaft doesn't spin until the clutch back and the clutch engages. Kind of a chicken before the egg thing. But then kind of figured out, okay, no, we could couple through a thrust bearing, and that ended up being an all-nighter, and kind of drew out the first design in on paper in 2D. Again, I'm a software engineer. I've been a mechanic, been fixing my own shit all my life. So got connected with a senior mechanical design or senior mechanical engineering student at BSU. He helped, we worked out the design together. Had a prototype made, put it in the bike, and the first one worked. And I was really, frankly, shocked. Awesome. And so decided to roll with it, and just took it from there. Built it out of my garage. About 6 months later, we moved into a small space and just kept growing.
That's pretty cool. I'm impressed that the first one worked. I don't know if anything else that happens that way.
Well, I got to tell you, there was a ton of luck. I'd set a budget for the whole thing, and I was really ready to give up if it wasn't going to work. And I left myself, I think my original budget was $5,000 total. I think I was about $4,000 in. So I had a little bit of room left to make some changes. And one of our big goals was to hit a price point, because we felt like $399 in 2002 was a kind of a mainstream accessory price point, right? Pipes were a mainstream accessories, but there weren't a lot of mainstream accessories back then that were $1,000, $1,200. And that meant we needed to have steel balls as our centrifugal mechanism. Revlock was using a lot of tungsten carbide balls. Really high quality steel ball bearings are, like less than a penny a piece, where tungsten carbide are over $1 a piece. So it would have a pretty major impact on cost. So we really had to get this. The critical thing was this ramp angle. And the math said we needed a certain ramp angle, and that was nowhere near where our force requirements we thought we needed to be at. And then we kind of looked at it and thought, it doesn't need to be that steep. And kind of started talking to the professor about it and said, well, yeah, pure friction, but you have vibration, right? And there's some theory around vibration and how it affects friction. And so we kind of came up with a guess of where it should be that kind of was in the window of where we thought we needed to be. Because again, we're still guessing on a lot of things about how torque delivery, like how much engagement force do you need at 2,200 RPM, like that initial engagement force? How much do you really need at 3,000, 4,000 RPM when the torque is really starting to build up? So we made a lot of guesses. Then we made a lot of guesses about, ramp angle and would we have enough friction for it to come down? And we kind of eyeballed it and we came up with an initial ramp angle. I believe it was 13.42 degrees.
Wow.
And it worked. And later on, when I had the luxury of trying different ramp angles, when we had our own CNC machines, I was like, let's try 13, see how it works. We put in made one with 13 degrees, did not disengage. The balls stuck out, they would go out, but they wouldn't come back in. I think 13.42 was like almost right there on the very edge. So we got really lucky. And it was purely a guess. So a lot of luck involved too.
I like that. I think there often is, and people, they want to credit themselves or whatever. And I appreciate giving luck its due.
Yeah. Luck and persistence.
Yeah. Can you talk a little bit about that persistence angle of it? I'm interested to know about like the evolution of the product over it was like 14 years that you were running the company?
Yeah, about 15.
Yeah. Okay.
Yep.
Yeah, I'm curious to know, like, you had your first model, it worked, you went to market with it, and then, like, things that you discovered as you went on, like the development of the product, of course, across all of the different motorcycles that you make clutches for today. There's that element of it, but then just kind of things you learned along the way.
Yeah, so I would say the most important things that I learned were probably business-related things. And the first one was we weren't a machine shop. We were relying on an outside vendor for that. And pretty quickly I recognized that all my margin was going to go to him. And he was a significant bottleneck in how quickly we could develop new products. And initially we were just trying to, go wide. We started with the CRF 450. Then I think we went YZ 450, YZ 250F. We just kept kind of growing out that way. And so pretty quickly recognized that we were not going to be able to control our destiny and really have a good, profitable business without owning the manufacturing. And I don't think I recognized it at the time, but absolutely, if you look at VersaBuilt as a company today, or excuse me, not VersaBuilt, Rekluse. VersaBuilt's my other company. The manufacturing technology that we developed was absolutely just as important as the technology itself, and really all the things around the manufacturing technology. It's a very high mix, low volume business. I think today Rekluse makes over 1,000 different part numbers each month.
Wow.
With typical batch sizes, I think down, well under 50 pieces. And when I sold it, I think our median batch size was about 15 pieces. And to do that well is extremely difficult. You can't do that kind of stuff overseas. And so developing that part of the business was really key to being able to grow and to manage it. But the other part was, I would say, just we kept advancing the state of the art. If we still had just the Z-Start clutch that we introduced in 2002, there's no way we would have grown as big as we did. We could probably still be a very niche business. Certainly that clutch worked, but it didn't have the kind of appeal that like a Z-Start Pro or a EXP Core XP kind of product would. And so, coming from a tech background, the culture that develops there is you cannot rest on your laurels. Everybody's coming after you. You got to keep, advancing the state of the art. And plus it's just, that's what's fun. That's what, it's not, I love dirt biking. I love getting on the product. I love, refining it and how it works and all those things. And I also liked designing and making them almost that much as well too.
So many questions. The first one is, can you get me a $399 clutch today, please? I bought a couple that cost a little bit more than that.
Yeah, I don't know if they still make like the base EXP version. I haven't even
probably
really
wasn't buying a base. I think I was up at 1,200 or something, but
yeah, I think when I left it, the most expensive was about 1,000. I think now they're up to about 1,200. Yeah. So. But
it's okay. I've enjoyed it, but I know stuff's expensive these days too. But
yeah. I won't comment on their pricing. I would not say that it would be any different if I was still involved.
Sure.
Metal has gone up a lot.
And labor and shipping, and everything. Yeah, we get it.
Yep.
The more serious question is something we were wondering about is, so you mentioned this, 1,000 different SKUs that get made every month. How do you figure out how to design for all the different bikes that are out there? How do you pick the bikes? Do you have to get a prototype and make for it? Or can you get part specs somewhere? Like, how do you even go about doing that?
So it's changed a lot over time. Rekluse now has a relationship with most of the major manufacturers. And sometimes that gets us early stuff, and sometimes it doesn't. Usually it's working with the race teams. We work with a lot of the race teams, so that'll sometimes get us stuff earlier. It will occasionally get us actual 3-dimensional models of the engine internals, so that we don't have to model them ourselves. But we don't have to make super sophisticated. They don't have to be super accurate models. We just have to check for interference points and things like that. So, the basic process would be either buy the dirt bike, or, we would put out ads on Craigslist, or just, we'll let the word out. Hey, if anyone buys, or the local dealers, one of this new model that we know has new clutch parts that aren't carried over from the previous year, have them contact us. We'll give them a free clutch. We'll take the bike. We'll, do some initial measurements. Then maybe 3 weeks later, after the prototypes are done, we'll bring it back. We'll do some basic, parking lot testing. And if it's different enough, we may actually ask for, hey, can we take it to the track, or can we take it, to one of the riding areas, so we can do, a little bit more in-depth testing. But we also, over the years, we've learned about predicting how the clutch is going to perform and what we're going to need to do to make that clutch perform. There's a few key parameters, number of friction plates, the, diameter of the friction plates. The most important is the primary reduction ratio, the ratio between the primary gear on the crankshaft and the gear on the clutch basket, because that affects how fast the clutch spins relative to the engine. And it also affects how much torque the clutch sees. Put all that kind of stuff into a spreadsheet, and then we can kind of model what kind of ramp angle we're going to need, what kind of springs we're going to need so it's disengaged at idle, and how much mass we're going to need in that centrifugal mechanism to get the kind of performance that we want. Sometimes manufacturers make decisions that that don't work good for auto clutches. I'll give you a great example. I have a newer, I think it's a 2021 Husky TXC 300, the cross country fuel injected, and they made the primary reduction ratio shorter. I think they went from about a 2.6 to 1 to like a 2.9 to 1. I'm kind of throwing these numbers out.
Sure.
I don't really know what they are, but it's something like that. But that slowed the clutch down, so we're not making as centrifugal force as fast, and it added more torque to the clutch. Think about that. Yep. If it's 2.5 to 1, that's like having a 2.5 foot long breaker bar. Right. If it's 2.9 to 1, that's like having a 2.9 foot long breaker bar, you can apply more torque. So it's kind of a double whammy. So like those kind of the most recent big bore KTMs and Huskies, the clutches don't, I mean, it still works well. I still ride it, but it's not as good as I like to see it. I think Rekluse is hoping to have something better, or hoping that KTM goes back to where they were. But sometimes we're limited by what the manufacturer does in how we can make the clutch perform.
How do you keep track of when the manufacturer changes a model? Because like I ride an old 2-stroke just because it's fun, but like, you know, it's weird years. It's like 06 to 12 or something, or you know, the same, whatever. Like, how do you even know when they're going to make a change, and how do you keep track of that?
You know, a new model year changes is a whole thing in the R&D department. You know, looking at all the press releases, first trying to identify who's saying they have improved clutch or this or that. Then when the parts fish come out, usually the parts fish come out before the bikes do. So then we can kind of get a list of what's changing.
I got you.
And try to attack those as aggressively as we can. It's usually the race teams that will be the highest priority, you know, and they'll give us the most warning. And, you know, like Rekluse right now is pretty tight with Yamaha, Husqvarna, a few others. I'm not, again, I don't follow it as closely, but we certainly work at like the factory level with those guys.
Yeah, fair enough. No, that sounds like a really interesting and complicated problem to manage. So
one of the many.
It is.
One of the many.
It is. It is. Again, it's one of Rekluse's big competitive advantages. Yeah. It's managing all that stuff. Like you know, there's certainly a lot of patents and technology around the products, but you know, it's a tough business to get into, and I think that you're going to find that is true with a lot of aftermarket power sports manufacturers. Mm-hmm. It's you know, especially if you've been
baked in. Yeah,
exactly. Yeah.
No, that makes a lot of sense.
So I want to dive into auto clutches and get into the nitty gritty of how they work and like their advantages and maybe disadvantages and all that stuff. But I just want to close off the conversation about Rekluse by just asking you if there's anything that like people don't know about Rekluse that maybe it's like a fun story or something like that, like something that's happened over the years that's like something not a lot of people know.
So early on we recognized racing is how we were going to really kind of get over the hurdle of that you can still be a man and ride a motorcycle with an automatic clutch, or a woman, or you know, you can be a good rider. Yeah. Although I think you know, it was mostly the male thing, even for women, I think. Racing really helped us there, and so pretty early on we bought what we called the Hoopty, and it was a 1994. Freightliner FLD, I think 120, you know, Class 8 semi-truck converted to a Class C with a garage in the back. And we went I hired a guy full-time, and that thing was on the road full-time for like 4 years. I think we put 350,000 miles on it, something like that. I think we got it about 2004. I think it was 2005 or 2006. We made our first trip to Sturgis with our new Harley clutch. And of course, we took the Hoopty, and spent a whole week out there. Had a great time. We always had a great time wherever we went. And on the way back, it was still a new product for us, and we had just made some like Gen 2 kind of changes that we weren't yet selling to the public. But I wanted to get more just highway time on. So on the way home, we were trying to make it back to Boise. It was kind of our second day of the trip back. And I'd been on this 2005 Harley Dynaglide for like 5 hours on the freeway following it was actually a different motorhome. It was a rented Class C. I just remembered that because the other one was at a race someplace. And, you know, one of those really ridiculously long vans that no motorhome should be that long. And then it was towing a pretty big trailer too, with a bunch of stuff in it. And I was falling behind on the freeway. We were just about into, I think, Bozeman. And all of a sudden I see something in the wheel well kind of blow up And then all of a sudden, there's this mist all over me, and then this choking worst smell, taste ever. And one of the tires had blown out and taken out the black tank.
Oh,
if you know what the black tank is.
Oh man.
And so this is only the first part of the story. So we kind of got through that. It was miserable. Now we're really late and trying to get back to where my kids are, get them from the grandparents and stuff. And so we're driving through eastern Idaho on like the shortest shortcut, this 2-lane road. And it's like late dusk and trying to go about 70, which is really too fast for that whole vehicle. I'm driving. My wife at the time is in the passenger seat. Another guy is just sitting in between us. And the Team America movie had just come out. And we kept watching it over and over again. It has the saying, Team America, fuck yeah. But we've been going, as we kept like selling our clutch or something, it was like, Team Rekluse, fuck yeah. And we're driving along, and these owls keep sweeping down and like almost hitting the windshield. And so we'd slow down about 55, and then all of a sudden, driving along, and I see like these like 2 little lights. I'm like, what the hell is that? And then we're getting closer and closer, like maybe backing off the gas a little bit, and I realize it is a full-size bull that's like 1 1/4 lanes wide.
Whoa,
and
right.
it's maybe 60 feet, or maybe 60, 80 feet away from it when I realized probably going 50 miles an hour in this huge rig, jump on the brakes and realize, okay, he's dead. We might both die. Can't do this. Get off the brakes and just kind of aim for its the quarter of it. I believe we missed it, but now we are off road, like probably 45 miles an hour, flying through, come to a stop. Everybody's like, okay, we all look at each other and go, Team Rekluse, fuck yeah.
That's so good.
That sounds about right. Oh man.
Oh man.
Yeah, a lot of great road trip memories. Ton of great road trip memories.
Yeah, that sounds like fun.
Yeah, I mean, in order to, at least in the power sports industry, if you're going to really make it, you got to travel around, and you got to be from one end of the country to the other.
Hit the races
frequently. Yeah. Very cool.
Yeah.
Well, let's just jump into auto clutches, because I want to know more about how they work. So I ran an auto clutch. I bought my KTM.
Inherited an auto clutch?
I inherited it. And I there was nothing wrong with it. I ran it for probably a couple of years anyways.
That wasn't it?
I don't know.
Anyway.
So I bought this bike and I ran it, and it was working fine, and I'd never run an auto clutch before. So I was like, oh, this is great. So I had like a good user experience from it. I put in a manual clutch in it because I finally burned up that clutch and decided it was time to try something else. And so I wanted to try out the manual clutch. So I just threw the stock KTM clutch. It's a 300 2010 bike. But I think for the purposes of just like setting a baseline, I want to know what are the fundamental principle of the auto clutch? Is it just centrifugal force, or is there more to it than that?
The basics of an automatic clutch are this. Normally you have the main components of a clutch are the basket, and the basket is coupled rotationally to the crankshaft. That's on the outside. On the inside is the transmission input shaft, and it's coupled to the center clutch. And the center clutch has drive plates that are coupled to the center clutch. And then the clutch basket has friction plates that are coupled to it. So when there's and there's typically most motorcycle clutches have eight frictions, 7 drive plates. So a drive plate in between each friction disc. And so normally those things are all compressed together through the pressure plate with pressure plate springs. And when you pull on the clutch lever, a throw-out rod pushes that pressure plate away from the clutch pack and disengages it. And then as you engage the clutch, there's when you start to let it go, it doesn't grab instantly. It has some progression to it, and that progression comes from a few different places. It comes from flex, And then it comes from displacing oil between the clutch friction plates and the drive plates. And so as everything starts to come together, first of all, you get some initial coupling as you're starting to push out the oil that's between the plates that's kind of gathered there. Then the pressure plate actually has a designed amount of flex into it. It's a spring within a spring. And as it starts to collapse all those plates together, the clutch pack itself has a little bit of spring to it too. And that starts to give more and more drive. And then the pressure plate starts to really fully come in and collapse the clutch pack. And you have a small amount of travel that is the flex of the pressure plate before all the springs engage, right? And that gives you your clutch disengagement, your clutch modulation, and then your full clutch engagement. And that happens irregardless of engine speed. In clutches, another important thing about clutches is clutches don't see horsepower. Clutches see torque. Horsepower is torque times RPM. And when I say clutches don't see horsepower, RPM does affect them very, very microscopically, just because centrifugal force kind of makes things want to come apart a little bit, but essentially it has no effect. A centrifugal clutch starts with the clutch disengaged. And now there's a lot of different types of centrifugal clutches. And even if you go back to our Z-Start versus our C-Start Pro versus our Core XP, they're quite a bit different. But I'm going to focus in on the Core XP because it's everything pretty much that we sell now. And it's most related to a stock clutch. And so the way it works is we have some way of spacing the pressure plate up off the clutch pack. Instead of this pressure plate being spring loaded into the clutch pack, it's spring loaded into an adjuster. So if it's a KTM or any hydraulic clutch, there's that little screw on the slave cylinder that you adjust that pushes on the rod and spaces that thing out. If it's an older cable clutch, we had an internal adjuster that pushed off of the nut. But that all those things are doing is like spacing the pressure plate away from the clutch, so it's disengaged, but the springs are still spring loading it. But right now they're spring loading it either into that nut or the throwout rod against the slave cylinder. And then in the clutch pack, we have a normal clutch pack, except we have one special friction disc. It's called that EXP friction disc. And that was really the best breakthrough that we made from a technology point of view over the years, going from kind of centrifugal balls that kind of pushed a pressure plate into a clutch pack to this friction disc that can expand. And this friction disc, it has, friction material on kind of what typically look like plates on either side. It's held together with springs. And then it has these wedges in it that are on ramps. And if you ever I should have grabbed one. I don't think I have one, and I have some in motorcycles. I don't want to pull one out real quick. But if you ever take an EXP disc and you push out from the inside on those wedges, you can see it kind of like expands out a little bit. Okay. So what happens is those springs that are in there that kind of squeeze everything together, they're designed to have enough spring force so that at idle speed, those wedges are all the way down and that friction disc is fully collapsed. But as you just crack above idle speed, there's enough force for centrifugal force from that clutch basket spinning for those wedges to move outward along those ramps and expand that friction disc, making it grow, which grows into the pressure plate, lifting the pressure plate off of either the nut or that throwout rod. It also has some deflection, so it has that nice smooth engagement until it goes fully expanded and it's got the pressure plate fully lifted off of that nut or the throwout rod, and now all that spring force is going into the clutch. And it depends on the model, but typically it takes from maybe idle to maybe 3,500 RPM on like a 450, so that force is all in the clutch pack from those springs. And typically we're making enough force by maybe, again, it depends on the model, somewhere less than that. Full force, spring force is typically 2 times to maybe 2.5 times, 3 times the maximum torque capacity of the clutch is usually 2 to 3 times as much as the max torque capacity of the engine. There's extra overhead there.
Interesting. Again, so many questions. Why 8 plates? Well, for example, so I've run the Rekluse the core manual with 12, something like that in it. I had it in a beta for a while. I think I get the concept, but it's interesting too, because I thought I understood clutches pretty well, and you've added a few pieces to it. I didn't realize about. I know there's oil in there, but I hadn't thought about the oil getting squeezed out of the way and that being part of the flex of the whole thing.
I learned. We could have an hour-long or 2-hour-long discussion about clutch chatter and dynamic versus static friction and the boundary layers, all this crazy stuff that I read a bunch of research papers by University of Michigan students that then went to work at ZF and in automatic transmission clutches, things like that. So, so your first question is why 8 plates?
Why 8? Is that standard? Yeah, or?
That's pretty standard. There's some are 7, some are 9. But I don't think I've ever seen a stock clutch with 10 plates or anything like that. So there's several reasons. So the reason we have multi-plate clutches, first of all, a clutch especially in a dirt bike has a lot of work to do. And so it is oil cooled. That oil there is primarily to pull heat away from the clutch. Cars use dry clutches. A BMW horizontal twin uses a dry automotive style clutch. Some of the Ducatis use dry clutches, and dry clutches have the advantage of a much higher coefficient of friction. Yep. And what that means is for any given amount of pressure, you can have more torque capacity. But they don't get rid of heat very well. So they're not good for a lot of on-off kind of use. That oil is really there as it's literally oil cooled. So having more plates gives more area for oil to flow through, and the steel plates are actually designed to absorb heat, and they act as kind of like a battery. When you have a really hard hit, a lot of energy that needs to be absorbed, that the temperature of those plates may come up quite a bit for a little bit, and then as you go down the straight, it comes down a little bit. If you have thinner plates, like let's say if you're running 60 thou plates versus 40 thou plates, 40 thou plates are going to have 50% less heat capacity, and in that turn, coming out of that muddy, rutted turn, you might hit a critical temperature in those plates and start to burn the paper on the frictions. And so having a thicker plate helps absorb more heat to prevent that kind of stuff. So heat. And then the last thing is total torque capacity. Torque is, a lot of people think, if I have a wider pad, that'll give me more friction. And that's not true. Area is not in the equation for torque transfer from friction. I've gone to battle with some mechanical engineers over this, and they finally okay, maybe you are right, but it is true. And in fact, I've seen performance clutches out there where they take a friction disc, they machine away some of the ID of it, so that now the radius, the center line of the radius of action of the friction has been moved out a little bit, and the clutch has a little bit more torque capacity. It will wear a little quicker because it doesn't have as much friction paper area. That's kind of trippy, right?
Yep.
So torque is radius of action. What's the center line of the diameter of the friction pad? What's the force going in, or pressure, really, it's pressure. And then what's the number of friction surfaces? Number of friction surfaces. So if you have 1 friction plate, 1 drive plate versus 8 frictions, 8 drive plates with the same amount of force clamping, 8 is going to give you 8 times as much torque capacity. So our core manual with the 12 plates, we sometimes do up to 12 plates.
Yep.
With the same amount of spring force, you get 50% more torque capacity. I think what we usually do is 25% more torque capacity with 25% less spring force.
Yeah, it did have lighter springs. I remember that too.
Yep.
Yeah.
Well, and that was one of the big selling features, I think, of that clutch was that the clutch pull was so much lighter.
Yeah, it was pretty. I mean, it was noticeable. It felt like maybe a third lighter, something like that. So that's about what you're saying. Yeah.
Yeah, and it depends on the model, and we've done a ton of work with race teams, and really we had a lot of success with automatic clutches in racing, both in off-road and motocross and supercross. Dylan Ferrandis, not last year, the year before, won. I could be wrong. I may be a year off, and I'd want to confirm this with somebody, but I'm pretty sure he raced virtually the whole outdoor season on an auto clutch. And so in a lot of it depends on the rider. Tends to be more riders that that are on the Rekluse program will run off-road or outdoor season auto versus a manual clutch indoors, especially since most bikes now have electric start. For a lot of guys, it was to prevent stalls. A lot of guys will still run them in mud races and stuff like that, but that multi-plate, that core EXP or the core manual clutch with the multi-plate was a big breakthrough for us. And with the racing teams, and honestly, I'm still surprised that like Kawasaki and even Honda and some of these other teams are not running it because it is such an advantage. Now, a lot of it does come down to personal preference, and there's also trade-offs. One of the things that most supercross, motocross guys will say is the torque. The core. The first thing they'll say is, "I am so much faster through the whoops." And we'll give a quick little tech dive on that. So imagine your rear tire, hits the face of the first whoop.
Yep.
Right, and then it gets airborne, and the rider's pinned. That wheel is now spinning up, and it's building kinetic energy.
Yep.
Right. Remember how I said it most clutches have like overcapacity of 2 to 3x.
Yep.
Well, when it hits the other side, there is a sudden shock load that's going through the driveline. There's extra energy that is trying to propel the motorcycle forward. But if the clutch doesn't have enough torque capacity, the clutch is going to eat some of that energy and convert it into heat. With the core manual, with the 12, I don't remember the name anymore. Sorry. I think it's the core manual torque drive. Core manual torque drive.
There it is.
It will drive the bike forward faster. So you can typically go faster through the whoops. You can get better drive landing off of a jump. Any of those situations like that. On a launch, on the start, you can transmit more torque. But where most guys have struggled sometimes with a core manual torque drive clutch on starts, if they do struggle on starts, is first of all, it's different. You can't, you have to modulate the clutch more, or you're gonna bring up the front tire more than you expect. And so a lot of guys struggle to get used to that. And so we make other changes to how the pad design, so that there's more oil there, for example. So there's more oil that's getting dissipated initially. There's other things that we do to kind of, get it to their preference. But usually there's trade-offs there between, on a core manual torque drive, between great start performance, what the rider is used to, and then the performance on the rest of the track.
That makes sense. Yeah, it's either one or the other, right? You need the engagement or you don't. Yeah.
Yeah, and I mean it's a spectrum though, right?
Sure.
And we've had a lot of riders become awesome starters with torque drive, and we had other riders that just couldn't get past the start. And a lot of those guys went back to the traditional stock friction disc. And stock friction discs for most manufacturers are outstanding. They really are. Their only downside to them is that they're made out of cast aluminum, and if they get too hot, they will fracture. and they don't dissipate. They don't have as much heat capacity as our clutch does. So another thing, when we've worked with race teams before, and go to Supercross, go look at Kawasaki, Honda, anyone that's not running our stuff, and they are typically changing clutches between practices, let alone motos, because those guys will go on a clutch that hard. Most of the mid-level teams that maybe are not getting that aren't quite as anal as your team, Husqvarna, or right. Some of the bigger factory teams, they're going multiple rounds or even seasons on one clutch pack. And many of the top teams were, back when I was involved, were going the weekend on the same clutch pack. So
that's wild.
much more heat capacity. And a lot of that, it's not, to be honest with you, FCC friction paper, if I could buy it, it's the most. FCC is a Japanese company that makes most of the clutch components for, everybody from Aprilia to Honda to Harley. Their friction paper is outstanding. We have some really good friction paper as well. Theirs, I would say, is a little bit better, but because we use a steel core on their friction plate, because we have more friction plates, we have way more heat capacity. So we can and we're transferring more torque, so we can do a lot more.
This is all super interesting. I had a clutch blow up from heat. Actually, a couple of them. That was a whole saga. I think
like 5,
3. Yeah, maybe. I don't know. I really liked the way that the Rekluse core manual worked in that bike, and I wish. So I'm on an older 2-stroke right now, and I wish I've had some clutch issues with it. I wish I could get one, but they don't sell that year anymore. So if you've got a connection,
which bike?
2006 XCW 300 KTM.
Yeah, they do. They absolutely do.
We're gonna have to talk after, because I would love. Yeah. I'd drop the money this minute if you had one. I called and they told me, yeah, we've got the basket, but we discontinued the hub and plates or something like that. I wanted the full kit.
Well, okay, so they probably don't make a basket. That stock basket is very good.
I thought that they actually had the basket and didn't have plates in the hub or something like that. I wanted the whole thing.
Yeah, definitely.
Because I put that in my beta and I loved it. It was aggressive and
so I'll check into it, and I'm pretty confident we can get something going for you.
Yeah, it would be cool. That'd make this whole conversation worth it for me personally. No, but I really liked it. I liked we do a lot of hill climbs, power hill climbs, and you're in and off the clutch a lot. We're really hard on them, and I liked the way the Rekluse was a little bit more aggressive, and and
the 06 300 was a monster motor too.
Yeah, I've had a factory clutch in there for a month, and something's wrong with the basket, but I destroyed the hub in a month of riding. So,
so if it's original basket, it's probably your rubber dampers that are bad. So pull the basket out.
I was thinking. Yeah.
Grab the basket, then try and that ring gear should, feel like it's got a bunch of rubber donuts which is what it has.
John replaced his. It's almost the same bike, and he's been into his, so we've done it. I just haven't. This bike's I bought it with fairly low hours, so I figured it'd be okay, but apparently not. So
mine had a good quarter inch of rotational.
Yeah, that's really.
It was really bad.
I wouldn't have thought that made that much difference. So I guess.
Hammering is
that's what's happening. I hammered the crap out of the hub. I mean, the hub looks like it's been in there 10 years, honestly. Like, it is demolished, and it's literally 4 weeks of riding.
Yeah. Well, we'll definitely connect. If Rekluse doesn't, Wiseco has a basket, because they're really good at like older model year kind of stuff.
Yep.
But yeah, we'll figure that out.
Yeah, it'd be cool. I'd appreciate it.
Now, I got a question for you guys.
Yeah.
If you want to come back to this, because I don't want to derail this.
No worries.
But
no.
Have you used a left-hand rear brake?
No. Mm-mm. I have not tried that.
Okay, well.
Sounds like it's on the list.
You need an auto clutch so you can use a left-hand rear brake.
Okay.
That's really its primary purpose for me. Now, that's maybe exaggerating a little bit, but not that much. But so we should spend a little time, but we should also finish up on what other tech questions you guys have about the clutches.
Well, I have way too many tech questions, but I do want to understand a little bit more about the auto clutch, because I ran it, and I used it like you would use a regular clutch. Like I still used the clutch lever, but like we ride a lot of hard enduro, right? And we do a lot of hill climbs, and I'm trying to understand what's going on in there when you're riding the bike. So like if you're just going to take a simple example, like a hill climb that's, you know, nice and level and doesn't have a lot of interesting characteristics, right? You're just going up a hill. You're going to get on the throttle. You're going to increase the RPMs of the engine, right? It's going to engage the centrifugal clutch more, right? Because the RPMs are higher. You're going to go up the hill, and as you're going up the hill, you're going to lose your momentum. You're going to rely more on the torque of the engine, and then you're going to lose the RPM speed, and it's going to decrease, which is going to allow the auto clutch to slip more, which is going to increase the RPMs, and that's going to increase the friction because of the auto clutch is going to expand again, and it's going to be playing
the force.
Right.
Yep.
It's going to be modulating the power as the engine hunts for that RPM range where it can engage the most friction. So it's going to be slipping the clutch on its own. Is there anything else to it other than that? Like,
so I'd say there's a few more things that are maybe a little esoteric. So first of all, like in that bike, the centrifugal mechanism is all done, meaning like it's way past what the torque of the engine is, probably by 3,500 RPM, maybe 3,200, something like that. So it's really not starting to come into play until you drop below that. And
it fully engages fairly quickly. Then I mean, 3,000.
It's pretty quick.
Low for,
on a 250F, it might be 4,000, right?
Sure, but you're not hill climbing at the bottom end like that unless you're lugging it. I mean, you're. Yeah.
So and again, that's still at peak torque while you're, not when you're just kind of babying it, right?
Right.
Babying it, it's fully engaged at 2,400 RPM, right? So it's a function of how much torque the engine's making, how much load the rear wheel can generate. Because if you're in something that's muddy, it's just that's going to be what slips, not the clutch. And then how much force the centrifugal mechanism is making. But if you kind of get into the esoterics of how it works, I won't name the guy, but early on in endurocross, there's a lot of motocross guys coming into it, and we became very, very successful in endurocross really quickly. And still are pretty successful. Although I think a lot of the top guys have now gone back to manual clutches. But even Cody Webb, I'm pretty confident raced multiple full seasons auto. But one guy that was a pretty top guy that came from the motocross world, and at first said, "No, I'm not going to use an auto clutch," and then just could put down some pretty good laps, but never very consistently. And finally we got him to try an auto clutch. And I talked to him at the end of that first season, and he said to me, "Thank you. I'm really glad you forced me to do this. I'm starting to go now back to the manual clutch, but your clutch taught me how to use the clutch in these situations." And really what happens is, and it's more pronounced on 4 strokes than it is on 2 strokes, but you are softening the delivery of torque between the engine and the rear wheel. When you're at low speeds like that and you crack the throttle open, you're getting, on a 2-stroke, you're getting a energy pulse every time, right? But if you look at what's happening to the rear tire, it's seeing this, right? 4-stroke is seeing this.
Yeah.
From idle to 3,200 RPM, the engine's seeing more of this, right? It's the auto clutch is chopping off the top of those torque pulses. It's allowing the tire to hook up better.
Yep.
a thing that I get with a lot of motocross guys, the first time they get on an auto clutch, is they say, I'm over jumping all the jumps coming out of tight corners. Right? They're coming down low. And one of the things that we would typically do early on, at least with when we had more control, or because early on it was only riders that were really interested, that were, motocross, supercross guys, typically guys later in life are looking for some sort of advantage, and would force a lot of these guys to run without a clutch lever initially. And they'd come back and say, I'm over jumping all the tight turns coming out of a jump. And it's because they're hooking up so much better because of chopping off those pulses. So it smooths out that kind of where you're most vulnerable to initially breaking traction, where you have high torque situations going right to the wheel, because you're not as prone to that if you're at 5,000 RPM. You got good traction. You're already the wheel's already seeing a lot of power. When you go from half throttle to full throttle, you're not as likely to spin up as you are when you crack that throttle open hard, especially leaned over or something like that. I'll give you one more anecdote to that.
Yeah.
I used to race. I raced a season of Supermoto, and the last race of the season was wet, and there was like 3 of us that were vying for the championship, and we all got together because we were racing in Utah, and it never rained there. And said like, are you guys going to really buy rain tires? And we all agreed not to buy rain tires. Well, I had an auto clutch. I could apply throttle leaned over in a corner from low RPMs, where the other guys were literally coasting through the corners. In a 4-lap heat race, I think it was 4 laps, I lapped the field because I could, apply that power at lower RPMs, where normally we were all pretty competitive.
Yep. No, I that makes a lot of sense. What about, so a lot of, we kind of split our time between doing these hill climbs because we've got the terrain for it, fortunately, and a lot of really technical enduro stuff, first gear, crawling the rocks and things like that. And for some of that stuff, as we've gotten better over the last couple of years, there's a lot of dumping the clutch to get the bike to pop the front end and do little things. I've never run the auto clutch version. John initially did, but how does it handle stuff like that? Is it gonna?
Yeah, it's. I mean, someone that's really, really tuned in and using the clutch between idle and 3,500 RPMs, modulating the clutch in that range, right. They can tell the difference because
that's where the auto clutch is also.
We're pushing the pressure plate up a little bit right in that range, so you're going to notice a little bit of finger movement right here. And there's really 2 reasons. I think a lot of guys, once they get really, really good, or they're doing really, really hard enduro, there's 2 disadvantages to the auto clutch. One is that they may be used to working there, and they may feel like they have the ability to do better. I would say that most guys don't. The bigger thing is a lot of those guys will use turning off their engine with their clutch out as a brake in certain situations.
Yeah.
And you lose that with the auto clutch unless you have the left-hand rear brake, and then it's just a little bit different, but it's better.
Okay. You don't have a ton of engine braking on a 2-stroke anyway. I've only done 2-stroke for the last 6 months or so. The years before that were all on big bore 4-strokes, so that's been a learning curve. But
is there any?
I mean, the other thing. Well, let me finish up with one thing on a manual clutch. I want you to try sometime next time you go out riding. Really try working your clutch, and it's a lot more noticeable on a 4-stroke. But kick up a gear and stay on your clutch and kind of find where, when you're between idle and let's say 4,000 RPM, you're really not pulling in the clutch as much as you're applying a certain amount of pressure to it.
Right.
And work that throttle so that you feel it slipping, especially as you're going over like rough, rocky terrain.
Yep.
And I think you will find your suspension works better and you can get better drive.
No, that makes a lot of sense. I don't know how, I wouldn't claim to be good at it, but we do try to do stuff like what you're talking about. And I've definitely felt what you're talking. So I could see that. Is there, I don't know how to ask this, like extra friction that's being applied just to the auto clutch as opposed to the rest of the stack, or is the whole stack still doing the normal?
It's all the same. It's all the same. Yeah.
Okay.
Yeah.
Right, because the pressure that's being applied by the auto clutch is transferring through the entire stack. It's not just on the auto clutch by itself.
So it's just like slipping it with the lever. It's not.
Yeah. And EXP, the old technology is Z-Start and Z-Start Pro. That was a pressure plate that moved into the clutch pack.
Okay.
The EXP stuff is all a expanding friction disc that moves the clutch pack towards the pressure plate.
Sits on the back of the inside of the stack, right, and pushes it out. Yeah.
Exactly. Gotcha. Yeah, but in both cases, all plates are involved.
Yeah. Okay.
Are you really just, for most riders, I guess, are you hurting yourself to be using the clutch lever, or is it better to let the centrifugal force modulate the power itself through technical terrain?
It depends on the situation, but if you need a big burst of power, use your clutch. That said, I've never raced any hard enduros. Other than the Idaho City Enduro, which I've done maybe 10 or 15 times, and it can be a pretty freaking hard enduro. So I've ridden moderately difficult terrain. I virtually never use the clutch lever to get my front tire up over an object. I use weight transfer and throttle control. That said, I think you do get better control on the clutch. You can be more precise in how you place, the angle of attack of your front tire if you're really good. I'm not really good. I'm a lot better using balance and knowing that it's not going to stall. I can have both hands on the bars. I'm not, my body is fully committed to the motorcycle. So I can do a good enough job typically. Would I say it's optimal? Maybe not for all cases or all people.
Is the centrifugal part of the clutch is rotating with the engine? Or right, like
that's correct.
Okay. So you can rev it up and get that engagement and
absolutely dump it. Yeah. Above 4,000 RPMs, you can't really tell it's an auto clutch.
Right. Yeah. That's what I was wondering.
And again, there's some models that will. Again, it has a lot to do with the OEM clutch. That if you pull the clutch in at really high RPMs, like 8,000, 9,000 RPMs, it will have a little bit of drag, maybe. But most people won't notice that during riding, other than maybe on a starting line. And even then, maybe a 250F you need up at 11, 12,000 RPM to dump the clutch. And when I used to work with 450 guys in motocross, supercross, they were more, I think, around the 6,000, 7,000 RPM range where they were dumping their clutch.
I noticed you just reminded me, I was going to ask earlier, I noticed a little bit of cold oil drag when I had the 12 plate manual clutch in the beta. Is that poor adjustment or that's to be expected?
No, that's to be expected.
Just because there's more plates pulling on the oil.
Yeah, and oil can make a big difference. It really can. Rekluse does sell their own oil, and it is very good. For years and years, we found that Chevron Delo 400 diesel engine oil was really the best all around performing. I don't believe I think they've gone to friction modifiers in that oil, and I don't think it's a good idea to use that oil anymore. You really need an oil that has no friction modifiers. So it's JSO MA for better rating. And honestly, the Rekluse oil it's not cheap. It's certainly not more expensive than like the modals and stuff like that. But they did a lot of testing, and it's designed for optimal clutch performance across a wide range of motorcycles. But that said, it can still be a very subtle thing. And you really want your clutch to perform not to cold temperatures, but to hot temperatures.
Yep.
Like I have my 2017 KTM 300. Whenever I get a new bike, I always do 2 or 3 rides on the stock clutch. Not a great clutch until it gets pretty warm.
Yep.
It doesn't have great modulation. It's a little draggy. But you just get it good and hot, and it works really good.
Yeah, it's interesting. I've noticed I've noticed something similar on the bike that I'm on these days. It always has to be, and really hot too. Not I ran it for 3 minutes and
you got to be working it.
Oil's got to be hot, and
Yep.
That's interesting.
Yep. So I got to ask this question because it just seems appropriate. I think most people associate Rekluse with auto clutches, right? And you guys have probably introduced one of the most hotly debated topics that guys who ride motorcycles like to talk about. I'm just wondering, over the course of the time that you were working with Rekluse, like, how did you skirt that whole thing? And
don't go on the internet.
Yeah, don't go on the internet. Maybe it's just like, just whatever.
I mean, the internet built our business for sure. Yeah. It was the racing really that did it, and there's a lot of people that can truly ride a motorcycle faster in a lot of situations with a manual clutch versus an auto clutch. And I said a lot of people, and what I think it's probably, the top 0.1% of riders, and maybe the top 0.01% of riders.
It's where everybody thinks they are, though, right?
Yeah, exactly. Now, that said, you can get on an auto clutch and you can ride an auto clutch really poorly. And it's pretty easy to ride an auto clutch really poorly. Put yourself 3 gears too high and you're going to ride it pretty poorly. You can fight it too.
I hadn't thought about that. That seems like a whole line of cautions or something that I wish we had more time.
Yeah. But most people will get on it and they'll naturally get accustomed to it and they'll be faster. The way we grew is the C riders started buying them, and then they beat the B riders. And the B riders like, what the hell? What's happening? And like, oh, okay, I'm going to try that. Then the B riders became A riders. And then the A riders became pro riders. Yeah. And then the pro riders, then one day Ty Davis calls me up and says, hey man, I want to try one of these. So
it's very cool.
Yeah.
I think we've eaten as much time as we asked for. You want to dive into what he's doing now?
Yeah, I mean, I could.
Trust me, I know.
Way too many questions.
I love clutches, and I could go forever. You want to come back on sometime?
I'd love to. I do want. I'll touch on that really quickly, but I want to touch on left-hand brakes. You guys really should try left-hand brakes.
Okay.
Brakes. Your left hand is a superior place to operate your rear brake from, and being able to so precisely modulate your rear brake. That's one area we've really struggled to get many pro riders to accept, but I think I could make most pro off-road motocross, I don't care who you are, faster with a left-hand rear brake.
Just because there's more finesse to it, or better understanding it?
Plus less compromise in your overall body position in difficult situations. Instead of, releasing some of your weight, shifting more of your weight to your left side so you can, modulate that brake. Your hands, your legs are planted. And, I still run one finger on my front brake, but 2 fingers on my back brake because I always clutch that way. But much better control. So.
I could definitely see that. No, we've started we started doing trainings with some of the pro riders who have classes and things, and obviously body position's a big deal. And I could definitely I've noticed having to reach for the rear brake throws off my body position. I'm not good enough to kind of keep it in line and do that as well. So
rocky downhills, fast, rocky downhills, technical.
Yep.
So anyway, especially where lines have to change a lot, things like that.
We've got a hill just like that. I know exactly what you're talking about.
Yeah. Okay. Cool. So what I'm doing now, I talked a little bit about, Rekluse's manufacturing.
Yep.
And, it's a really difficult manufacturing, very high mix, low volume. And so as you're going through, you're learning a lot of things about how to do that better. Mostly has to do with like standardizing things so that you can change over quickly between parts, go from making this part to that part, building your system so you understand what your customer demand is and reacting to that real time, all that kind of stuff. But we still recognize that one of our big problems was the people loading and unloading the machines. It's a shitty job. It's an asynchronous activity. I'm doing this like, oh shit, that machine's flashing its green light. Oh, that machine's flashing its green light. Should I finish this or should I do that? It's just, people aren't good at doing that kind of that particular kind of thing. It's also a very boring part. So we thought we have to get robots loading these things. And 10 years ago when we started, we said, we brought in these robot experts. Said, we got. I think at the time we had 250 part numbers, 400 part numbers, something like that. So we want to automate all these part numbers. And the guy laughed at me and said, no, we can automate one part number. And so we said, screw that. We figured out how to make a clutch. We can figure out how to load a machine with a robot. And it was a similar type of thing. We had a breakthrough one day, like, well, shit, that's a stupid way to do it. If we could do it this way instead, it would make adding new parts to the system, the automation system, easy for anybody that knows how to run machines. That's another problem with automation, is it usually takes some robot expert to get new parts integrated in the system. But also, more importantly, we could keep those changeover times between parts down to a couple of minutes, where traditional automation was days to change over, So we kind of made a technological breakthrough in how to use automation in a high mix, low volume environment. And it turns out that if you look at the world's CNC manufacturing machines, it's not something that's widely tracked, but kind of asked a lot of experts. Most will agree it's somewhere between 90 and 95% of all CNC machines are in this high mix, low volume space. The rest make automotive parts, right? It's mostly automotive, that type of thing. So, we started. My middle son was kind of just out of high school, and he had been working for me part time. And I said, "Hey, man, this might be fun to do. Let's kind of go after that." And then my older son kind of came along as a software developer, and we just started building it. And it's been really interesting. We were way, way, way ahead of our time. When we introduced the product 10 years ago, like, nobody was making robot automation for high mix CNC manufacturing. And now it's still much smaller here in the US than it is in Europe, but there's probably 30 companies that would claim that they're kind of in that space. So we have some really unique patented technology to make milling, not turning, but milling much easier. But I would say it's just been really, since the COVID got really painful, like in 2022, that people kind of like said, okay, this is something we got to do. So off to a really great start this year. Fourth quarter was a little weird. I think it was a little weird for everybody, because
it's been a weird
what's the economy going to do? So it's like I said, I'm passionate about dirt biking. I'm passionate about anything with an engine. I use a lot of gasoline. Gasoline is, if it was beer or gasoline, I would definitely give up beer. But I really like manufacturing too. And it's fun doing that, fun solving complex problems. So if anybody out there is in a CNC manufacturing facility and you're doing changeovers and you think you can't do automation, we can help you automate. And generally, pretty safe to say, as a general rule of thumb, twice the production, half the labor. We usually do twice the production on about 20% of the labor.
Wow,
that's pretty impressive.
It's important for this country to do this too. We as a country for 20 years, going back 20 years ago, we started, as soon as China was $1 cheaper, we moved it over there. Right. And a lot of that's short-sighted overall. But our main disadvantage compared to foreign markets from a manufacturing point of view is the labor cost. It still needs labor. But when you can get 10 times the output with the same amount of labor input, we can beat China, and we can be more competitive as a manufacturer.
Yeah, that whole concept of outsourcing has come back around big time the last couple of years. That's an interesting topic. So I'm very cool.
Yeah. It's so cool to see how you've taken one company and you learned so much from it, and you developed a really cool product, and then you're like, okay, well, I'm going to take this, I'm going to start another business, and then I'm sure VersaBuilt will be, a just
I like
equally impressive.
I like the family angle too. I've got kids who are early teens, and they help us out a little bit here and there. But I'd love to get them more involved. So it sounds like there's hope for that.
Oh yeah,
That's cool.
Yeah, it's fun. It's fun.
So-
It's been a lot of fun. So
Very cool.
Yeah, I think
I had a ton of fun. We always learn a lot.
we're gonna have to do another one of these because I came up with
yeah.
We've got pages
I would
and stuff.
Yeah, sorry guys. I tend to ramble on. Would love to do another one with you. I love talking about this stuff, and I love dirt bikes. Just love doing it. So, and also, guys, you got to think about a trip up to Idaho.
we do.
We do think about it. The problem is getting away from day jobs and this little business we run and trying to figure out how to make it happen. But
so here's how you make it happen. You guys are in SoCal. We're in SoCal.
yeah, SoCal, inland from LA. I don't know, Inland Empire area, Riverside, San Bernardino.
So directs LAX to Boise on Alaska a month in advance is like $200.
That's not too bad.
Plus pack your bag. We have motorcycles here. It turns
I was just going to ask what
extra ones.
Where do I put my bike? Okay.
I think I'm back down to under 15 motorcycles.
Oh, okay.
So you got a couple spares.
I got a couple spares.
I got to take you up on that.
All right, we're gonna have to come ride with you.
Yeah, please do. Please do. Love to have you guys.
That'd be a ton of fun. I'd love to come see all the stuff you're working on too. I get a kick out of the manufacturing process. I don't know a ton about it, but I love looking at it. So that'd be cool.
Yeah. Cool. Yeah, we can do a podcast from Rekluse headquarters.
There you go. There you
awesome.
go. That's the next one. We'll schedule it.
Okay.
All right. Thank you.
Appreciate it, man. Thanks so much.
All right, gentlemen. Yeah, great talking with you guys. Great meeting you guys.
Cool.
Have fun.
Yep. Thanks.
Be safe.
Yep. John, you got to keep bringing these very technical people onto the podcast because I don't even care if we have an audience at this point. I just want to talk to these guys and learn how to get better at whatever.
Well, I have a very
levers,
exciting
clutches,
roadmap of people to
riding
talk to.
techniques. This is starting to turn into training session for Kel and John.
No, so what I would need to do when I reach out to people is hey, can we talk for about 3 hours?
Can we have an afternoon with you?
Yeah. Because I'm starting to realize how insufficient an hour is to cover just about anything you want to talk about.
We don't
It's
even
really
scratch the
hard.
surface. We don't even cover the range of topics superficially.
So I have 3 pages of questions, right? And we got to right about here. So
we literally got through the intro and what is an auto clutch. And then a couple of
he explained some really good things about how it works and the mechanics and all the things that you don't normally talk about. But I wanted to break down the individual pieces. Rekluse makes their own springs. They make their own basket, hub, pressure plate set. They make
So you've got material science. You got oil flow. You've got the physics of torque.
Oil. They make their own slave cylinders. They make their own friction and steel discs where I don't know why the Rekluse friction pads are the shape that they are, but he touched on that a little bit. I don't know why there's different hub designs in the way that the steel plates integrate with the hubs.
Those pins versus the gear versus
and there's all different kinds
spring types.
There's all this stuff. And I was I did not get a chance to ask any
No, but
questions.
he said we can come ride with him.
And we can have another podcast, so I'm going to have to start.
Dude, we got to fly there and do one in shop and really get here's the dowels of the new clutch. Here's why they went that way. Really get into this shit for real.
Yeah. I would love to do that.
That'd be a ton of fun.
I mean, I don't know. I haven't really seen.
I've earned it, John. I've broken enough fucking clutches at this point. I have earned a trip to Rekluse.
They need to educate the broken clutches out of you.
Please save me.
So
it sounds like the race teams are much harder than even I am on their clutches, so I don't feel quite so
you're
bad.
not replacing a clutch every.
No, it went a whole month.
There you go. every moto. Is that what he said?
He said every practice session.
Ugh.
We put plates in.
Well, I definitely don't do that. I've been running the same plates for 3 years.
Yeah, clearly you don't know how to ride a bike. Anyway, this was a ton of fun. We appreciate you guys coming along for the ride. Before we let you go, we're really quickly going to pitch. We make chin mounts so you can put a GoPro or other action camera on your helmet in the best possible way. We make those for a ton of different helmets. We're coming up on probably 100 models or something like that now. Links in the description with all the details you'll need to know about that. And we've got some cool guests coming on. In fact, we're thinking about going twice a month instead of once a month because we've got that many cool guests lined up and we're having so much fun with these conversations. So we appreciate you coming along. Like and subscribe so you don't miss the next one and all our other garbage videos.
Yeah. This is where all of our effort goes.
This is where we have the most fun. And we'll see you next time. Thanks, guys.